All right. Good morning, everyone in the
Morning,
Americas.
everybody.
Yeah. Good evening to the people in Europe. Um, Today we have a very special session. We are joined by Florèn from the Netherlands, and he's going to be talking about a really interesting topic. In just a few minutes, I'm just going to take a minute or two to just do the usual introduction that we do during these sessions. So I'm going to share my screen now. Um, so this is, right now I'm just showing what we're going to cover today. So today is August the 6th, and what we're going to be covering is robotics and conveyor tracking. And again, this is the guest that we have today, Florèn van Olden from Festo, Netherlands. He works for the EASI connection, or he works for this group, and he's a connection engineer there in the Netherlands. He's going to be actually leading this conversation today. We are also joined by our legendary host, Alejandro Lopez, and
How are
he's
you
going to be asking
guys?
questions and also answering any questions that you guys might have. Remember, you can ask questions in English, Spanish, and French, and we'll
Yes.
answer them. And today, there's a special
In Dutch.
treat where you can also ask questions in Dutch. Um,
Yeah.
so one other thing that I wanted to mention is you can always reach out to us. Here are our email addresses.
Yeah.
You can send us any questions that you might have. There's the email address from Florèn as well. And I have another couple of things that I want to touch on. But Alejandro, do you have anything to say?
No, just to say welcome everybody. Thanks for joining us. It's great to have you guys here. Para todos los que hablan espagnol, están invitados para hacer sus preguntas. Pour tout le monde qui parle français, vous êtes bienvenus à faire vos questions et puis on va faire le mieux pour répondre. No olviden de hacer sus preguntas. Si tienen algún tipo de pregunta luego, pueden enviarnos un correo. Ahí están las direcciones de nosotros. And go ahead, Sandro. I think we're good.
Yeah.
Good to start. This nice guest we have today, and let's hopefully everybody can learn a little bit about this. And if not, then we have the videos in our YouTube channel, so you guys.
Yeah,
can
and that brings me to, I'm going to show you that right now in just a couple of seconds. The one thing that I wanted to mention today is that right now there is an ongoing event. There's actually in North America, there's the Festo experience. You can join this virtual trade show that it started yesterday, but today is the last day. So you can always go, there's the link, festoexperience.bfairs.com, or you can just scan that QD or 2D code.
Sure.
And before we jump into the actual topic for today, going back to what Alejandro just mentioned, I wanted to remind you that, where is my show?
Yeah, all the videos are always stored in our YouTube channel from Festo US.
Right.
You guys are more than welcome to join us there and then recap on what we already, all the topics that we already visited, and then you can go ahead and watch every single session. And if you have questions or anything, you can maybe put your comments or send us an email.
Yeah, this is the session from a couple of weeks ago. You can see there Alejandro was showing us Mr. Gantry, and again you can find this in the Festo US channel on YouTube. Anyways, that's it for me. I'm not going to take any more time for today.
Yeah.
Florèn, welcome. Thank you very much for dedicating some time. For joining us from the Netherlands. We know that it's already late over there, and you're working extra hours right now, but. Yeah, welcome, and tell us a little bit about what you're showing today.
Yeah, today I'm showing you the tripod. It's not a Festo tripod, it's just a general generic tripod that we're going to use with Festo motors and Festo controllers. Also, Mr. Gantry that was described in one of the other sessions can also be connected via the robot library. The robot library is just a general a way of connecting your drives. Just another way, and I hope to make it easier for you to connect. Yeah, the name of my department is written like EASI, but it's pronounced easy. So my function in Festo is everything that's difficult, I will make it easy for you.
Nice.
So yeah, I will show you a small presentation as a start, and when it's getting boring, please interrupt me, and then I will make it a bit more.
That's also important, Florèn, that everybody on the call, this is not just to let him talk. We want to ask him questions. If there is anything that we want to know, is the time to to put your questions on. You can raise up your hand and then let us know what is the concern or question or any comment also. The idea here is also to see what is in the market, what you guys know, maybe something that we need to learn also. So
Yeah.
go ahead, Florèn.
You can start sharing your screen, Florèn, because we don't see it yet.
Yeah.
Okay. I try to
see a nice picture or nice video of the tripod.
Sorry.
There we go.
I have to double click. Yeah. So this is the correct picture then?
Yeah, we're looking at the visualization with some controls.
Yeah, so this is me, and I'm going to talk about robotics. This is one of our bionic robots, so totally run on air. So you don't only have electric robots, but also air-driven robots. And this is just a general Gantt. You can see that you can. I don't know if the movement is correct in the video. Can you see it?
Yeah, we can see it. Yeah.
So we have here just the general point-to-point movement, and if I go down a little bit, then we see CNC movement. So this is just an H gantry, so with one conveyor belt going through the entire machine, no moving motors. And this is also an option that was already there, but today we're going to focus on really point-to-point movement with combined access. That's actually what the robot library is, to make combined access better accessible for everybody. So I hope that I will, So this is just a general overview from CODESYS. So in CODESYS we can create an access group. This is what the robot library does. So you see here a long list of very different kinds of kinematics that you can select. So here you see the gantry, but today I'm going to select the tripod.
Now on the left hand side, you mean, right? On the picture on the left, it says Festo Robotics, and then it says Kin EXEH. So that would be an H kinematics, right?
Yeah. So these are all different kinds of kinematics. And these are the Festo ones that are predefined. Also the X and Y, so the Cartesian system is already defined for you in this kinematic model. But you can also use the generic transformation, so kinematic models, so that you can just connect everything.
That's very important here, because as you mentioned, we're talking about the Festo gantry, but or Festo tripod or Festo kinematics, but not necessarily only for that. Also important to mention is the transformation is there. So your transformation, you can use it with any mechanics. You can get mechanics from somewhere else and refurbish this with Festo motors, configure the mechanics to appropriate kinematics, and then it will work.
Yeah, and also combine old and new. Huh?
Yeah, and Florèn, I think this might be a good moment because we're touching on the kinematics. Can you stop sharing your screen and can you show us the video on your iPhone?
Spotlight on
because we want to see. Yeah, you stop sharing your screen, and then I'm going to make the spotlight on your video on your iPhone. And can you walk us through the kinematics that you have there? Can you grab the phone and show us? Because Alejandro was mentioning right now that this library will work with any kinematics, right? So right now what you're showing us and what we can see here is, so this is a tripod from some other brand, right? So this is a tripod, but what we see there is that this is using Festo motors, right? So we see,
And here we have the controller, so they do the controlling of the conveyor belt, but also the wrist and the rotation on the arms. And here we have our Festo PLC, which also does the controlling, where the robot library runs on.
That little thing, that is the motion controller, actually, the one on the left, right?
Yeah, this one. That
one is the motion controller.
And this is the big one. We also have a compact one that's a bit smaller.
Okay.
Something nice about this one.
Profinet, this one has a Profinet port.
Exactly.
So here. And the smaller one hasn't, so it's more compact.
Something interesting on this, Sandro, is what I like about is you see the interface on the left of the controller. Right now, as Florèn mentioned, is Profinet, but the same connectivity is for Ethernet IP. So you can connect with pretty much everybody in the market with the two most used field bus or more present field bus in the market. And I guess all the network is on EtherCAT because it's a very high speed network, of course.
Right. So that's a good point, because all of these motor drives or servo drives are running on EtherCAT. That's my understanding, and it doesn't matter that they are running on EtherCAT. What Alejandro is saying is that I don't see that. What I see is I can connect to a controller like another PLC that might be running Ethernet IP or Profinet, and I can still control all of these kinematics. Correct?
Yeah, correct. And you can also, these are all servo drives, but you can also connect stepper drives, for example, in the same field bus. So
Perfect.
That's no problem.
So okay, sorry for interrupting your presentation. You can resume sharing your screen and continue with your slides.
So I will share screen 2 again.
Any questions so far? Let's ask the audience. Any questions? No, I don't see any questions here so far.
No.
Go ahead, Florèn.
Everything clear up to now. So then, yeah, when you select your kinematics, every different kind of kinematic model has, of course, different types of engine. For example, they have only two motors, and a tripod has 3 arms, so 3 motors, but also the rotation. And in this case, I also have a wrist connected to it. You can add more motors. And there's one thing really important about using these motors. There are two different ways of controlling these kinematic models, and it's called the direct mode and the linear mode. And the linear mode is really just like you know it. You give in an acceleration and a velocity. But the direct mode is using the limits of your motors. So if you have a very unrealistically high no limit setup, then your machine will go light speed and do something dangerous. So yeah, keep your limits realistic in your motor configuration, so that you can effectively use direct mode.
Can you limit also these dynamic values for the whole axis group?
Yeah, you can. Yeah,
Okay.
That's a separate function block. And you can also always do this multi-level as well. So you have for different safety levels, you have a different function blocks to limit the entire axis group. Yeah.
Okay, good.
And yeah, in this case, because it's tripod, I also had to limit the way the arm moves, because you only make very small movements. It's if you do a 360 rotation, then your entire tripod breaks apart. So it's also very nice to give in your.
That's also actually important to understand, because in some mechanical system like tripods, they use linear axis to create the whole mechanism. But in this case, you have the motor directly attached to the arm with an elbow as an extension. Right. So that is also key, because if you turn more than 360, then you break the whole thing.
Right. And that point that you're touching on right now, it's the one that's on the top that says software limits, right? And it says it's activated right now, and it says I can move from -85 to +35. The problem for the people that are more on the mechanical side and not so on the control side, the problem here is that the motor itself doesn't know what it's connected to, right? So the motor is just an open shaft, and it's just turning to whatever position you want. Via software, what we're doing is we're limiting the motor to turn at a certain degree, so it doesn't exceed the mechanical limitations, right? And that's what Florèn was mentioning right now, that with this and the velocity, acceleration, deceleration in jerk, we can guarantee that the mechanical limitations are not going to be exceeded.
Yeah, and also this is also multi-level safety, so you can also limit these axes on a hardware level in the motor controller, but then you will get an error as soon as you exceed it. And if you do the software limits here in CODESYS, then you will get a soft error, which is more easily resettable. So then you prevent a bigger disaster. Yeah.
Okay.
So So yeah, the most easy way to use the robot library is a function block called startup access group, and this is really an ensemble. So pick together a bunch of function blocks that will give you easy access to your system, and also there's a visualization included. So when I made this access group, you see here the function block. I just have to put in the name of the access group. In my case, this was tripod, and here it's access group. And I have connected all the basic settings for the for the system.
something important here is that when people start programming this kind of kinematics without having an axis group or having this kind of library, they have to create their own structure for MC power, MC reset, MC home, MC move, and so on. And you have to create an interpolator and so on. So now things become more and more complex. In this case, you have one axis group that takes care of everything,
Right.
which is nice. It simplifies definitely the work.
Yeah, so you can do so you don't have to control every motor individually. It will be seen as a group, and it will only be seen as a group after you do MC group enable, so motion control group enable. Before that, you can just individually control your individual axis still. And this is useful for systems where you need to do the homing on an individual level. So maybe for safety reasons, you want to home your kinematics in a specific order. So after the homing is complete, you can switch over to the group mode, group enable, and then it will see it as a group in total. So you can first power on all the
So Florèn, I see the controls here. Can you switch back to your web visualization? I would like to see if we can get the kinematics moving for the people that are anxiously waiting to see this thing. Like maybe they're like, okay, but what does it do, right? Like So let's take a look at that.
So I will switch over to my other screen. Oh, sorry, I was already on this screen, so I should close my presentation for a moment. Sorry.
This is a nice little product. Now the tripods are really well used in packaging industry, and it is a product that has a niche market already established.
So do you see my visualization already?
No, not yet.
Oh, sorry.
Not yet. We see the tripod. Wrong. Yeah, now it's coming up.
There it is. Yeah.
Okay. So and the webcam is still open. Yeah. So what do we want to see? Just a general U-pick?
Yeah. So here what you have is I can see 3 motors on the top. I would imagine that these are the motors for the tripod, right? Okay. Now we see some movement. So we see the movement on the visualization. On the bottom left, you have a circle that says tool, right? Is that the actual tool that's turning, rotating?
I'm not sure what you're pointing at.
Yeah, the gripper. Yeah, that's the gripper.
That's the gripper. Yeah. Okay.
The gripper is now detached because we had a top secret testing gripper on it, so I had to remove this for the.
It's fine. It's fine. Okay. So.
But now I can just make the speed a little bigger because it's now pretty slow. So I will put it on 2 meters a second and make the acceleration a bit higher. I was a bit on the safe side with
that's nice. So now you can see the full synchronization of all the motors using the Robo library.
These for the people that are not very knowledgeable or know a lot about CODESYS, the nice thing about this visualization that Florèn is showing right now is that this is open in Chrome, in Google Chrome. He doesn't have to have any special software or anything to visualize an HMI. He can just use a regular web visualization.
Yeah, so, you just see the address bar here, and I'm just connecting to the website.
Florèn, can you stop sharing your screen, and so now we can focus on your camera? Yeah.
Sorry, what do you want to do?
Can you stop sharing your screen so we can focus on
you see a bit more. Okay, I will put it on again.
Yeah. While you stop sharing your screen, I'm going to
something interesting also here, Sandro. Yeah, go ahead. I'll mention something here in a minute.
There we go. Now we can see it.
Yeah.
And also in this movement, you see some blending. So the corners are rounded off, and this will make it a bit quicker. And I can
That's
also,
important too. Yeah. That's very important what you mentioned, Florèn, because blending is also a method that is very used in the packaging industry, especially when you are picking up something from a specific high and coming to a different level and placing into the final destination. So you want to blend all those movements so you create a full circle across, so you minimize the cycle time and optimize the final speed or throughput.
Blending for the people that are not don't know a lot about these things. So usually what you have is you have a movement that might be like this, right? I don't know if you can see my screen there. So you have a movement.
We can see more or less.
Like
a square or kind of triangle.
Like a trapezoid. So what you do with blending is you actually you actually make this a little bit smoother. I'm gonna show it again. These portions over here, you make them smoother, so you don't have that strong change in acceleration, right? So you're smoothing a transition of movement. That's the blending that they're talking about. Now,
I have a
Florèn,
slide later on that shows it a little bit in my presentation to see the different forms of blending, because we can blend on the actual path, the rounding off the edges of your U-pick, for example. But we can also, this is really path-based blending, but we can also do velocity-based blending, and this is more optimal for your kinematics, for example.
Yeah.
That's nice.
So
That's nice that you have that in the library.
I was going to ask Florèn, is it possible to get your camera on your phone a little closer to the kinematics? We might have some people on the call that they've never seen a tripod before, maybe. Or also, one other thing to mention, a tripod is also known as a delta robot. So
same thing.
In literature, it's the same thing. So this is how it works. He has 3 motors attached on the top, and you can see that there's an arm linked to each motor shaft. Now, the magic here, the reason why he has to use this robot library is because imagine if you have one motor only turning by itself, it doesn't know what the other motors are doing, right? So by using this library, what he's doing is that he is now able to link. You remember that at one point he mentioned the axis group. Now with this axis group, he's able to link the motors so they are synchronized to accomplish a common positioning task. That's what's happening here.
Or
right?
path that you want to follow.
Or path, yeah. Because so tripods or delta robots can be used for pick and place applications. They are actually perfect for these kind of applications. But they can also be used for dispensing. We've used it before in an application where we needed to dispense some sort of glue or something on a windshield, on a car windshield, and they could do it with this, right? So that's a good example. Now, Florèn, on the invitation, we also mentioned something about tracking. Can you show us the tracking functionality here?
Yeah, I can. I have to switch screens.
While Florèn is getting prepared, let's talk about tracking. Tracking is very important in the market because allows you to not to stop the product as you move from one point to the other. The idea is as the part is coming to a particular area where you have a camera, the camera will be able to take a picture, get this location of the product, and synchronize all the mathematically configured. So as the conveyor is moving with the part, the tracking will take care of moving that part virtually also, and the tripod in this case will approach the part, grab it as it's moving, and place it in a different location. So there is no stopping point, which is the nice thing about that for packaging industry, where you need a very high volume in less time or minimum time.
And usually, as Alejandro mentioned, with tracking, usually what you have is a conveyor belt, right? So you have a conveyor belt where all of the parts or whatever you're picking are going through, and you pick them while the conveyor is moving. So actually the robot is able to detect what's the position of that part, and that's why it's called tracking, because it's tracking it along the conveyor. So let's see what's going on here. Okay, I see the conveyor moving. Let me put the spotlight on this video again.
Yeah, I will move towards the conveyor belt.
Yeah, and that's perfect. I think it's good that you have it slow right now so we can see what's happening actually. Okay, so we see that there's like a cross on the conveyor. There's a cross on the conveyor, and what the tripod is simulating right now, it's simulating that it's picking a part or something, or it's dropping a part to the side of the conveyor. But now notice that when it goes above the conveyor, it doesn't matter that the cross is moving, it's tracking it, right? So you see the conveyor, it's moving, and the tripod, it's tracking it. This is helpful because of what Alejandro mentioned, to save cycle time, to be able to pick multiple parts that are going through a conveyor belt and so on. It's tricky though, because I mean, it's not, sometimes you might be like, how do I do this? And that's exactly why we have. Yeah, that's exactly why you hire engineers to do this kind of thing.
And important to show here, Florèn, if you can point it out to the camera, which is the one above, then the camera is getting the picture and tracking the information and send it back to the controller, synchronize with the encoder, and then send the final location and positions in real time to the servos.
Exactly.
Yeah, normally you just, what I did in this setup, because I use this the setup for multiple multiple tests and
exercises.
Exercises. Yeah. So what I can do now is put normally you put a camera in the beginning of the conveyor belt, and the track conveyor belt just generally saves where your object was at a certain moment. So because it's not very handy to put your camera here, because half of the time your robot is in the way of your picture.
Yeah, the camera can be pretty much anywhere, as long as you have enough time to synchronize the whole thing.
No one has mentioned something that's important. How do we know what's the speed of the conveyor, right? And I know the answer to this, but I mean, maybe the participants also here in the call, they know the answer, but I'm just going to mention it for people watching this on YouTube later on. There is an encoder on the conveyor. Even if you're using a servo motor or another kind of motor, there is some kind of feedback. So the general system, the motion controller, can know, oh, this conveyor is moving at this speed. So now you can see here, this is a servo motor that is linked to the conveyor. And remember that a servo motor has an encoder, right? So now we can pass this position and know, oh, the conveyor is turning at this speed.
Right. What you normally see in the market is a conveyor with a regular VFD and a standard motor running, and you attach the encoder directly to the shaft, so you can see that.
Yeah, and you can also you have here three Ethernet ports. So the three bottom Ethernet ports, they are all suitable for connecting encoders. So one is an encoder entry point for just your motor. But if you want to synchronize your motor with for the conveyor belt, for example, you can also add in a second encoder and use this from CODESYS to read in your device. So you don't even have to buy an extra device just to get your encoder input.
Yeah,
they will all be synchronized with your EtherCAT.
Yeah, no, that's a good point also. We're running out of time. We're getting up to the end. No, that's fine. I just want to mention that we're almost 5 minutes up to the end. Something to mention here is what is really important is to know what kind of system you want to attach to this mechanics and what is the speed. Something important on this is HGO, Handling Guide Online, for standard kinematics from Festo helps you to create that, to design that and come up with a mechanical system that will be able to be controlled with this robotics library. As Florèn mentioned earlier, we're running in this case with a third-party tripod, which is important too, because sometimes you want to retrofit something that is already maybe not working correctly, and you can attach all motors and drives and controls to that. And that's a good thing about the Festo robotics library, that you can integrate that seamlessly in existing systems.
Right.
So, Sandro, you want to mention something else? I don't see any questions so far here.
No questions so far. Okay. I think I'm gonna share something that was I was discussing with Florèn this topic before this session. It was interesting. So let me share my screen here. So Florèn was telling me that in the Festo office in the Netherlands, they were having some issues with people not parking their cars correctly, and they were like, hey, you're not parking your car where it should be at. And what they did is, next time if you don't park your car, we're just gonna build something and we're gonna pick it up and place it at the right spot in the parking lot. Okay, so just be careful the way.
Need a big crane for that.
So I just wanted to show this video because I thought it was interesting there. It's the same concept, the same kind of like a tripod, and it's using a gripper just to pick up these little toys or these cars, right? And just putting it in a certain position. I don't know. I just thought it was funny there, interesting.
Florèn, anything else that you want to show us right now?
Yeah, there's one final thing that is I think very important for the robot library. Now we have the conveyor belt in a straight line connected to the to your tripod. It's really in a 90-degree angle, but it's fairly easy to just put in a different angle, and your robot library will automatically connect it. So if I have this.
You want to share your screen, or?
I will share my screen. 1 moment. Press some buttons. Okay. Sorry for that.
No, it's fine. So what else? Okay, you're gonna share your screen in just a second.
Yeah.
Again, people in the audience, you can unmute yourself. I see several people there connected, so you can unmute yourself or just type it in the chat and we'll address it. Okay, we see your screen now.
Yeah, so this is the conveyor belt tracking block. And you saw earlier the sensor that was exactly 2 meters in front of my my tripod. So every time when I want to input a new a new object, I can just execute the track conveyor belt function block, and then it will be loaded in a moving moving system.
So this will be the coordinates that will be passed by a vision system, for example.
Yeah. So this is the entry point for your vision system. But we see now that the conveyor belt is in a 90-degree angle from our tripod, because the X and I are turned against the conveyor belt. But if your conveyor belt is, for example, moving slightly upwards or downwards or in a 45-degree angle, it will automatically correct this in the rest of your kinematics.
That's nice.
So that's pretty nice. Yeah. And so
it simplifies a lot.
Yeah, you see the conveyor belt origin. So this is really where your conveyor belt is, and then also your object. That's the initial object position. This is how your object is located on the conveyor belt. So you can also make offsets in that. That simplifies it. The trajectory calculation quite a lot.
Florèn, I have one last question before we finish for today. Is it possible, because we know that CODESYS is something that you can just get from the internet, you can just download it and install it. Is it possible to run this in simulation mode? Like if I didn't have the hardware, can I also run this in simulation?
Yeah, you can. Yeah, it's quite easy.
That's great, because I had a person that I know ask me recently, hey, I want to learn more about how to program in PLC. I want to learn more about how to do motion, how to do all of this stuff. I told him, dude, you just download CODESYS. It's an IEC 61131 standard that you can use to program in ladder, in function blocks, in structured text. And today you're showing us the true capabilities of CODESYS. I mean, we can do motion, we can do tracking. There's a lot of stuff that you can do. It's just a matter of you wanting to do it, right?
Yeah, and I can show you very quickly how to do it. So these are now the drives that are all connected. Do you see my screen already?
Yeah.
So these are arm 1, arm 2, arm 3 of my tripod, real-time tracking, everything. But it's fairly easy to put them in virtual mode. So you can also now it's online, so I cannot do it. But when I go offline, I can put my axis into virtual mode, and in this way I can also do the testing of my entire movement, my entire UPIC, every trajectory calculation already before I have my machine built together. So you can
that's nice thing about
even finish your complete machine before it's actually built.
Perfect.
And that's also a nice, and the only thing that you have to do is just mark away the virtual mode, and then you can connect it.
Cool.
Florèn, the library right now, the library that you're using, is that library available in our Festo website, I believe?
Yeah, it's if you have a CODESYS, so if you download the newest CODESYS from the CODESYS website, or from our website, the Festo website, then you can just install it. And when you install it, you go to Package Manager, Tools, Package Manager, and in there we can see here the CODESYS soft motion, and you can just use the newest version. Every version gets better, the tracking gets faster, everything is getting better, and then update it, and then you will be all set up to do everything that I showed you today.
That's good.
Perfect.
That's good.
All right.
Yeah, well, for everybody on the call, you were more than welcome to visit our Festo website, and then under support, you can download that and try it. You don't have to have any PLC. Because Florèn, can you show us also where you can simulate the PLC under debug? Then you can completely simulate without even having the PLC physically.
Yeah, so you first have to go into offline mode, so not being connected anymore, and then just turn on simulation, and that's all you have to do. So there now in red there's a simulation button here, and you can
you can pretty much run all the code for virtual drives, virtual PLC, not having anything, and then you can do all the testing, which is good.
There's only one thing. There's only one thing. The license is half an hour. So if your system mysteriously stops working after half an hour, you know that you can just buy the license or restart your machine.
Call us.
Yeah. Okay. Well, perfect. Okay. Thank you very much, guys. Florèn, can you stop sharing so we can just finalize today's session? thank you very much for the people that joined us today. I know this is really, it's a struggle for us because it's such a complex and nice topic that we can spend hours talking about, but we just wanted to give you a taste of it, and so you can know what we can do at Festo. You saw the Festo servo motors, you saw the Festo servo drives, you saw that we can control any kinematics, like in this case, this is not a Festo kinematics, this is just another brand kinematics. What we did is we also covered this in CODESYS. We briefly went into into how it is done, but I think we pretty much covered what we wanted to cover today. And remember that you can watch this session later on YouTube in case that you missed a portion of it. It should be up in maybe a couple of days, and then you can watch it there on YouTube. And questions or anything else, you can type them on the YouTube comments, and we'll get back to you. And we're gonna have another session, as you know, every other week. So 2 weeks from now, on a Thursday, we're gonna meet again, and we're gonna talk about another interesting topic.
August 20th.
Yeah. So that's it from my side, Alejandro, Florèn. I don't know if you want to say some last words before we finish this meeting today.
Yeah,
I'll see you next time.
Florèn, go ahead.
Yeah. I'll see you next time. I enjoyed being on your show.
Thank you so much. Thanks for you know, taking some of your time and spending us with us. Thanks for everybody on the call, and thanks for everybody watching this maybe later on. That was a nice topic. For sure, we need to cover more of this, but for now is the end. Thank you so much to everybody.
All right. Bye-bye.
All right, guys. Bye.